what I wanted to try and focus on for this session of revision was some sort of slightly more difficult questions. All right, so we may need to talk about some revision of basics as we go along, but this is supposed to challenge you just a little bit, not very, very, very much, but it is supposed to challenge you a little bit. Okay, so the first question gives us the sum to infinity of a convergent geometric series is 32, and r is equal to a half. They want us to find or determine the difference between the sum to infinity and the sum of the first 5 terms. Okay, so I want this to be as interactive as possible. Is there anybody, after reading this information, anyone who can tell me what it is you think you should do first? How are we going to take the information that's given to us and use it to make equations? What do you think? So the sum to infinity of a convergent geometric series is 32. How would we write that? So you can't find the pattern just yet. What would you do with this? So the sum to infinity of a convergent geometric series is 32. What would you do with that? Do you think, Matrix? I wonder if it would help if I put some. Okay, so in Nhlanhla, you could use that to find A. So maybe what I should do is my sum to infinity formula. So sum to infinity is A over 1 minus R. Okay, where's the 32 going to go? Where's sum to 32? Where's 32 going to go? 32, I'm going to substitute in. There we go, Nhlanhla. Well done. Sorry, was somebody going to say something?
I've muted Sbongile because Sbongile, I think you're just talking in the background, but not really talking to us. So.
Oh, okay. All right, that's fine. Okay, so Mamelo, Unati, Lebogang, Johnny, and Nhlanhla, yes, lovely. Okay, so you're going to sub in 32 for sum to infinity. You're going to sub in your R, and that means that we can work out the value of A. All right, so that means that 32 would be equal to A over a half, and now we can cross multiply, or we can multiply both sides by half. It's the same thing. So A would be equal to what in this case, Matrix? A would be equal to 16. Good, Nhlanhla, you're on the ball today. That's lovely. Okay. So now that means you know what A is. You know that A is equal to 16. And you know what R is. You know that R is equal to 1 over 2. The rest of the question tells us or asks us to find the difference between the sum to infinity and the sum of the first 5 terms. So we know what the sum to infinity is. We know that it's equal to 32, right? So if they want us to calculate a difference, the difference is between the sum to infinity, which is 32, and the sum to the first 5 terms. So this is what they want us to calculate. So we know what the 32 is. How are we going to calculate the sum to 5? How are we going to calculate the sum to 5? What formula are we going to use? So remember, our geometric SN formula is A r to the n minus 1 over r minus 1. So if we want to calculate the sum to 5, a is equal to 16. We know that r is equal to 1 over 2, and we know that there are 5 terms in this pattern. Okay, over a half minus 1. So we would substitute in as follows. What would that give us as our sum to 5? What are you guys getting as an answer? That's it, in Nhlanhla, quite right. Okay, you should be getting 31. Okay, so the difference between the sum to infinity and the sum of the first 5 terms is going to be equal to 1. That's it. Well done, everybody. Okay, are there any questions? Any questions, Matrix? Don't forget to take screenshots. There are no questions, you sure?
Yeah, either you ask now or forever hold your breath. I think Tabia is asking on the chat.
Okay, what would the mark allocation be? Okay, so I always work backwards for mark allocations. Okay, so there would have to be a mark for the answer. Then there would have to be a mark for calculating the sum to 31. All right, so subbing accurately into the correct formula. There would have to be an accuracy mark on calculating that A was equal to 16. And generally speaking, there would be a mark in there. Okay, so something like this could potentially be out of 5 marks. Okay, so this would be considered problem solving, but it's not difficult problem solving. Nonjabulo, 32 was the sum to infinity. 31 was the sum to, was the sum to 5. The difference between them means you must subtract. So 32 minus 31 is 1. Okay, any other questions? Okay, all right, Nonjabulo, no problem. Okay, I don't think there are any other questions there, but that's what you would get your marks for. Okay, so again, you have to sub into the correct formulae. You're not going to get marks for subbing into incorrect formulae. All right, now we're going to do something that is a little bit more difficult. Okay, this involves some sigma notation. Remember, we were talking about sigma notation the last time, and a lot of you said that you wanted a bit more practice with that. Okay, so I found these questions for us to practice. Just on the side, very quickly, before we go on, right? When it comes to sigma notation, okay, there will be a number at the top, there will be a number at the bottom, and then there will be a rule in brackets. So for example, if your rule is 3 times 2 to the n, okay, can anybody tell me what does the number at the bottom mean? What do we do with the number at the bottom? Naledi? Go for it.
Ma'am, we substituted into the 3 times 2 to the power of n.
Absolutely. So the number at the bottom is where we start subbing in. Okay, where we start subbing in. Okay, what does the number at the top represent? Okay, Who else has got a hand up? Ria Betswe? See, you've got a hand up. What does the number at the top represent? Banele?
Koloko.
Oh, sorry.
Sorry, Charlie. I just see Koloko is talking, and I think Koloko is talking to us. But Koloko, you need to make sure you unmute because you are muted at this moment. So that's why we cannot hear anything. There's a button there that when you click on it, instead of having a cross there, it will just unmute you so you can talk to us. I'm not sure if you can see what I'm talking about. Sorry, Teacher Lee. We can continue.
No problem.
Go, keep trying. Okay, they should be on your device where you can unmute yourself.
All right. I think Banele managed to unmute. Banele,
Yes.
what does the number at the top represent? Okay, so Nonchabulo says the number of terms. Iviwe says the number of terms in the sequence. Amahle says the number of terms in the sequence. Mako says the last number. Oratile stops subbing. Okay. Rufenswe, the last number we have to sub into the sequence. Okay, so there's some varied answers there. Some of them are correct and some of them are not correct. Okay, so I see Banele and Koloko have still got their hands up. Teddy, did you want to say something?
Hello, ma'am. It can't be the last term because then the number of terms will be 5 minus 2 plus 1. So it's either the last number or the end point, as some say.
Okay, all right. So you're right. It is the last number we sub in. Okay, so a lot of matrics think that the 5 at the top means that there's 5 terms in the pattern. It doesn't mean that. Okay, it's the last number that you start subbing in. So for example, if you start subbing in at 2 and you finish subbing in at 5, there are not going to be 5 terms in the pattern. Okay, so that's really, really important. Okay, Lebogang, I see you've got a hand up.
Oh, it's afternoon, ma'am.
Afternoon.
Ma'am, can I just ask, ma'am, the only time, for example, it would have 5 terms is if we start at 1.
Correct.
And
Correct.
so, ma'am, so the terms in the pattern will be, is a 1 more than the number at the top?
Okay, so not necessarily. Okay, so it's the number at the top minus the number at the bottom plus 1. Okay, so you guys have to learn that. All right, so it's the number at the top minus the number at the bottom plus 1, and that will always give you the number of terms in the pattern. Okay, so in this particular case, there are 4 terms in the pattern. Okay, so we can see the 4 terms when we sub in. So this would be 3 times 2 to the 2. That would be the first term. Plus 3 times 2 to the 3. Plus 2 times 3 to the 4. Plus 2 times, sorry, I'm just moving over here. Sorry, let's just rub that out. Plus, sorry, that wasn't supposed to be a 2. Sorry, hang on a second. Wrote that the wrong way around. Plus 3 times 2 to the 4 plus 3 times 2 to the 5. Okay, so there you go. There's the first term. There's the second term. There's the third term. There's the fourth term. Okay, so there are 4 terms in the pattern. Okay. So again, the number at the bottom is where we start subbing in. The number at the top is the last number to be subbed in. The number of terms in the pattern is always the number at the top minus the number at the bottom plus 1. Okay, so that's really, really important for us. Okay, so if we were going to calculate this, we would call this the sum to 4 Okay, it's a geometric pattern. And then we could go ahead and go and sub into our geometric sum formula. Okay, so this would be the value of A. This would be the value of AR. This would be the value of AR squared. This would be the value of AR cubed. Right, we could work out what R is by dividing term 2 by term 1. Okay, and then we would have everything that we needed in order to be able to calculate the sum to the first 4 terms. All right, so this is very important before we can begin answering any questions on sigma notation. This rule that we are given doesn't necessarily always need to be geometric. Okay, this rule can be arithmetic, and then we would use our arithmetic sum formula. Okay, I just happened to use an example of a geometric one. Okay, but the same thing would apply if it was arithmetic. The number at the bottom is where you start subbing in. The number at the top is where you would end subbing in. And the difference between the number at the top and the bottom plus 1 would be the number of terms. Okay, that is the same for all sigma notation. Okay, so after you have subbed in and you have got the first, say, 3 terms and the last term of your pattern, then you would be able to see for sure whether it was arithmetic or geometric. If it was geometric, use the geometric sum formula. If it's arithmetic, use the arithmetic sum formula. Okay, are we all good with that? Does that make sense? Any questions? Yes, I can do that. All right. Okay. So now back to the questions that we have been given. All right. The first one that they have given us, all right, is prove that the sum from k equals 1 to infinity of 4 times 3 to the power of 2 minus k is convergent, or is a convergent geometric series. Show all your calculations, and this is out of 3 marks, right? What do they want us to show here? There's something very specific that we need to demonstrate. What would that be? How do we show that something is a converging geometric series? What do they want us to calculate? Okay, in Nhlanhla, you just got your signs the wrong way around, but that's perfect. Okay, this means you need to show. See, there's a couple of other people with hands up. Marco? Do you want to say something? You're welcome to unmute, Marco.
Ma'am, don't we do that formula where we're gonna write -1 less than r greater or equal?
Okay, absolutely. That's what you want to show. Okay, but you're proving this. So you need to calculate the value of r and show that it is a number that is bigger than -1 but smaller than 1. Okay, good. Well done. So that's what we have to show. All right. So what they want from us is the value of r. Okay, so this question wants us to work out the value of r, and r needs to be a number that's bigger than -1 and smaller than 1. That proves that the series is converging, right? So when they ask us to calculate the value of r, all right, what do we need to do with the information that's been given to us? So what are we going to do with the k equals 1? What will we do with k equals 1? We're going to sub it in, absolutely. So we want to generate the first few terms of the pattern. Okay, we're going to start by subbing in. So the first term in the pattern is 4 times 3 to the power of 2 minus 1. The second term in the pattern is 4 times 3 to the power of 2 minus 2. The third term in the pattern is 4 times 3 to the power of 2 minus 3. And so on it would go to infinity. Okay, because this is a sum to infinity question. All right, I think, Mako, your hand was up from last time. Koloko, did you want to say something? I don't know if you, Lebogang?
Ma'am, can I ask, will the sequence always converge between -1 and 1?
Yes, so in order for it to be a converging geometric series, your R value has to be a value between -1 and 1. So if your R value is, say, 2, your series doesn't converge. If your R value is, say, -3, your series does not converge. All right, so what converging actually means is it's related to your exponential function. So let me show you what they're actually getting you to do here, right? So when a series converges, you are talking about an arithmetic, a geometric sum. Okay, so if it does this, so if your exponential function does that, or if your exponential function does this, those pink ones are converging. Okay, so the word converging means that it's coming towards a certain point. So it actually converges at the asymptote. The reason why you cannot calculate a sum to infinity for something like this, that diverges. Okay, so this goes up to positive infinity and it keeps going. This one as well, it keeps going down to negative infinity and it keeps going. So the blue ones are diverging. Okay, so that's what they mean by converging. So we are working with exponential number patterns that have an asymptote. Okay, so it's either approaching its asymptote from this direction or it's approaching its asymptote from this direction. Okay, so as n or x gets bigger. Does that make sense to everybody? Are there any questions? Yes. Okay, so your teachers, theoretically, your teacher should have showed you that when they started doing this section with you. It might be something that you forget, but I think it's nice just to remind ourselves what it means. Okay, so have I done this correctly? Let's just check. So 4 times 3 would be 12. That would be 3 to the power of 0. So that would be 1 times 4 is 4. And then this would be 4 times 3 to the minus 1. So that would be 4 over 3. Is that right? Hang on a second. I feel like I've made a mistake here.
Not
No, I
with the ones
haven't.
that we
I
have
haven't.
there.
Okay.
You
All
haven't
right.
made any
Okay. Sorry.
mistake.
I don't know why I
Yeah.
thought I've had a really hectic day. So you'll just have to
Oh,
forgive me and
sorry, teacher.
it's okay. But just if I do make a mistake, you must just tell me. All right. So you're quite right, guys. R is equal to 1 over 3. All right. So what we could then say, all right, therefore the series converges because R, which is 1 over 3, is greater than -1, but smaller than 1. Okay, so where would our marks be allocated for a question like this? Well, we would have to sub in and get our terms, all right? So we would need A, we would need AR, and then together, writing what R is, together with our explanation, so this bit over here, that would be worth the 3rd mark. Okay, so remember this represents A, this represents AR, this represents AR squared. Okay, good. Well done, everybody. Are there any questions? We're going to go on to the next one. Yes, Nhlanhla.
Good afternoon, ma'am.
Good afternoon, Nhlanhla.
Ma'am, does it matter if you don't sub in like the value for R, if you just leave it as R?
Oh, you mean if you don't? No, you see, for something like this, when you are proving something, there has to be a conclusion. So you have to calculate something and then make a conclusion about it. So yeah, I would say for this, if you didn't do that, then they would probably penalize you, because that's the whole idea. All right, is that it's greater than -1, but smaller than 1. Okay.
Okay, thank you, ma'am.
No problem. Leanne, you were asking a question. You said, how did we get 1/3? Can anyone explain to Leanne how we got 1/3? Oh, there's a bunch of people with their hands up. Cool. All right, Naledi, please tell Leanne, how did we get 1/3? What did we do, Naledi?
So basically what we did, we took T2 and we divided by T1, and then we find the difference. Yes.
Okay, you find out what R is. Perfect. Okay, well done. That's lovely. So you said 4 divided by 12, and that's where we got the 1/3. Perfect, Naledi. Thank you so much. Yes, there we go. And a lot of you are saying that in the chat as well. That's it. So 4 divided by 12. Yes, well done, Nhlanhla. Well done, Mamelo. Nonjabulo, divide the second term by the first term. Beautiful. Okay, so all of you are getting that correct. Well done, guys. Okay, let's have a look at the next question. So that one was a little bit easier. The next one out of 5 is going to be a little bit more difficult. All right. So again, it's a sum to infinity question, and it must be related to the previous question because we've got the same pattern. We've got a sum to infinity. There are a couple of differences though. In 3.2, we had k equals 1. And in 3.2, we've got k equals p. Right? So we've got 4 times 3 to the 2 minus k equals 2/9. Determine the value of p. Okay, so let's break it down a little bit. All right, this is our rule that we're working with. Okay, we also know that we are calculating a sum to infinity. And the other bit of information that they've given us is that k is equal to p. All right, they want us to calculate the value of p. What does this bit over here mean? I'm just going to use a different color. What does this represent? The 2/9. So we know it's a sum to infinity. We know k equals p. We've got the rule. What does the equals 2/9 mean? Okay, Koloko, go for it. What does it mean? Shame, I think Koloko is still struggling to unmute. Okay. There were some good... Sorry, is that you, Linda?
Yes, sorry. No, Koloko has unmuted. Koloko, you can talk. Sorry, Teacher Lee. Because we succeeded. There we go.
Yay.
2/9 is our SN.
It is. Okay, it's your sum to infinity. Okay, so it's not the value of R, guys. If they give you a sigma notation with a rule and they write equals a number, that number after the equals is your sum to infinity or your SN. Okay, it's not your R. Okay, so the bit in the purple is your sum to infinity. The value of the sum to infinity is 2/9. Okay, so sum to infinity is 2/9. Okay, so some of you said that, some of you said that it was R. So I'm glad that I asked that question. Okay, now here at the bottom, they're telling us k equals p, and they want us to solve for p. So remember, the number at the bottom is where we start subbing in. Right, so let's just get this down. So we've got sum to infinity. We've got k equals p. Our rule is 4 times 3 to the 2 minus k. And it's equal to 2/9. Right? So the number at the bottom is where we start subbing in. Okay, so if I begin by subbing in, all right, I would have 4 times 3 to the 2 minus p. What would be the next number that I subbed in? Okay, so some of us are saying 2p. Okay, isn't it always one more than what it was? So if you start subbing in at p, what would be one more than p?
Oh, one more.
One more. Because remember, if we start subbing in a 2, then we sub in 3, then we sub in 4, then we sub in 5, then we sub in 6. So it's always one more, isn't it? There we go, boy Shepo. Okay, so the next thing that we would sub in would be p plus 1. Then the next one we would sub in would be p plus 2, etc., etc. Okay, so there's a little bit of simplifying that needs to take place, but let's do that next. So we've got 4 times 3 to the 2 minus, okay, and then we need to sub in p plus 1. And then we've got 4 times 3, and then we've got to sub in p minus 2, etc., etc. All right, and it adds all of this, eventually adds up to 2 over 9. Okay, we need to solve for p. So let's simplify things a little bit. Okay, so we've got 4. Yes, Naledi?
Ma'am, could you explain here where you wrote 4 times 3, 2 minus, open brackets, p minus 2? Okay, you fixed the mistake.
Sorry, I fixed my mistake. I beg your pardon.
Yeah.
Sorry, as I was saying, I've had a long day today, so you guys are just going to have to forgive me. Yolanda, you're going to need to be on the ball and make sure that I'm not writing anything that's incorrect here. Yeah, I'm so sorry about that. Please don't be afraid to say something if I do make a mistake. Okay. All right, thank you. All right, so then we've got here 3 to the 2 minus p, plus here we're going to remove those brackets. So that's going to give us 2 minus p minus 1. And then here we've got 4 times 3 to the 2 minus p minus 2. And it doesn't matter how many of these terms, the infinite number of terms, we add them together, we're still going to get 2 over 9. Okay, so just sorting this out, 2 minus p plus 4 times 3. So we've got 2 minus 1, which would be 1 minus p. And then over here, we've got 4 times 3. So the 2 minus the 2, it would just be negative p plus whatever it was adds up to 2 over 9. Okay, so we need to solve for p, all right? What do you think we need to do next, Matrix? What do you think we need to do next? Do we find R? Okay, the lady said we need to find R. Do we work with our bases? Getting closer. Good, William. Someone had a hand up. Amahle, what would you do?
Good evening, ma'am.
Good evening.
So first you'd have to work with your bases and then find your R by taking T2 and over T1.
Okay. All right. So what do you think that I should, I mean, you could do that now, couldn't you? All right.
Yes,
You
and
could
then
work.
find the value of P as well.
All right. Okay. Now, if we found the value of R, all right, how are we going to use it though? What would we do with the value of R? Okay, Tamir says, okay, and I'm glad you made that point, Tamir. Tamir says, ignore the bases and work with the exponents. All right, now, the reason that we can't do that yet, Tamir, I hope I'm saying your name correctly, is we would do that in a situation like this. So imagine you've got, this is a gross oversimplification, but if you've got 2 to the x equals 2, sorry, move my mouse out the way, equals 2 to the power of 3. Right? Then you can say my bases are the same. So I'm going to, after I've equated my bases, I'm going to equate my exponents. All right. But the problem here is that you are adding. Okay, so you've got this term plus this term plus this term plus this term, etc., etc. So that only works, the table, that only works when you are multiplying. So if you have got 2 to the x times 2 to the 3, then you can say I'm multiplying like bases. I can add my exponents. There are no exponent laws for when you are adding. There are no exponent laws when you are adding. Well, something that we could do here in order to simplify this a little bit is there is a common factor that we could take out. What is the common factor we could take out? Exactly, we could take out the 4. So if I take out the 4, we'd then be left with 3 to the 2 minus p plus 3 to the 1 minus p plus 3 to the minus p plus etc., etc. equals 2 over 9. Okay, what could I do then? Okay, that would help you work out the value of R in Tlantla. Koloko, what would you do next?
Ma'am, we multiply every time by 4.
Okay, you can now, that's right, Teddy. So we could divide by 4 on both sides. So that would give us 3 to the 2 minus p plus 3 to the 1 minus p plus 3 to the minus p plus, all right, and then on this side over here, we would have to take 2 over 9 and we would need to divide that by 4. What do we get? 1 over 18. Is that, oh no, it was a 1 over 16, 1 over 18. Okay.
1 over 18, yes.
1 over 18, absolutely. Okay, so we're getting closer and closer. What do we think we should do now? Okay, we can't take out another common factor, okay, because we can't take out the base. Can't add the exponents either, because there's no rule for what we do. Okay, so if you want to divide, what do you want to divide by? So are you going back to saying we should work out the value of R? So if we go back to working out the value of R, we don't need to do it this way, but we can. We would end up with 4 times 3 to the 1 minus p over 4 times 3 to the 2 minus p. So 4 divided by 4 would disappear. When we divide like bases, we keep our base and we subtract our exponents. So that would give us 1 minus p minus 2 minus p. So R would be equal to 3 to the power of 1 minus p minus 2 plus p, right? So this is not going to help us because we would end up with minus p plus p. Our p is gone. And we've got 1 minus 2. That would give us that. We already know that R is equal to a third. All right, remember, we did that in this question over here. Right, so calculating the value of R doesn't necessarily help us in this situation. We've got to think of something else that we can do. Any ideas? Okay, so we could take 18 into the numerator. That would be 2 times 3 squared. And that would have to be to the power of -1. So I don't think that really helps us. Okay, multiply both sides by 18. Okay, well, if we multiply both sides by 18, oh, sorry, I rubbed the 18 out. We would end up with 1 on the one side, and we would end up with 18 times all of these terms on the left. Banele.
Good evening, ma'am.
Good evening.
I think we should say 18 shift fact on the calculator and say it will be equal to, and then we're gonna put some brackets all over to -1.
Okay, but even if we do that, it's not going to help us simplify what we've got on the left-hand side.
I think it's ruled because
You think it will?
Yes, because if we change 18 into prime
Okay,
base of
but
3, which will be 2 times.
so it would be 2 times 3 squared, but all of that would have to be to the power of -1. So you'd end up with 2 to the power of -1 times 3 to the power of -2. But how is that going to help you? Because you don't have this in front of each of your terms. Also, you are adding. Okay, so the problem here is that there is no rule for when we add like bases. Okay, the rule is for multiplying like bases, but there is no rule for adding. Okay, so Leanne says term 2. Okay, but the problem with that, Leanne, is that it is not an arithmetic sequence. Okay, remember, this is a geometric sequence. Okay, so that's not going to help us either. Okay, and Nhlanhla, what do you think we should do at this point?
Ma'am, I think we should find the value of A, which is the first term.
Okay, all right.
By
so
using the sum to infinity formula.
Okay, so we know that A is equal to 3 to the 2 minus P.
Yes.
Okay, so our sum to infinity, so where would you go back to? So, or do you want to work with this? Because that would have also been A if your sum to infinity was this. Okay, so tell me what you think we should write.
Okay, ma'am, what I did, I said 1 over 18 is equal to A over 1 minus 1 over 3.
So did you put in the 3 to the 2 minus P up at the top here? Did you do that?
Okay, ma'am. What? No, ma'am. I didn't.
Okay, all right. Would that be okay though? I mean, if we have a look, we've got to this point over here where we've simplified. All right. You're quite right, Nhlanhla. This is the value of A. We all know from the previous questions, we've got that. We all know from the previous question that the value of R is equal to 1 over 3. Because we've taken out the 4 and we've divided by 4 on both sides, we know that our sum to infinity is 1 over 18. So if I sub in my 1 over 18 in place of my sum to infinity, in place of A, I'm going to write 3 to the power of 2 minus P. And in the denominator, I'm going to write 1 minus, and remember r was equal to a third. Okay, good, well done. All right, yes, this is now going to work. So I wanted us to sort of get stuck at this point and then start thinking about what else we could do. It's also really important because you need to know your exponent rules so well. Okay, so if you think about it, okay, there are no rules for adding bases or subtracting bases when it comes to exponents. There are rules about multiplying like bases and dividing like bases, but there are no rules for adding. Okay, so because there are no rules of adding, that's why we've got to go and think of something else. Okay, so let's try and do this now. Let's see what we end up with. We've got 1 over 18 equals 3 to the power of 2 minus p, and then 1 minus a third would be 2/3. Okay, yes, so we can multiply. Let me just move this down and out the way. So quite right, Teddy, we can multiply by 2 over 3 on both sides. So that means we would need to take our 1 over 18. I'm going to say, so we said we were going to multiply by 2 over 3 on both sides. So I'm just doing that on my calculator. All right, so what are we going to get next? I see there's some people with hands in the air. Banele, I don't know if that was you earlier. In Nhlanhla, what did you get? Sorry, actually.
Oh, ma'am, I got 1 over 27.
1 over 27. All right, that's fine. And then here you had 3 to the 2 minus p. Is that correct?
Yes, ma'am.
Okay, good, well done. And then what did you do after this?
Okay, what I did after this, I used the log formula.
Okay.
Where I said 2 minus p is equal to log the base as 3 to the power of 1 over 27.
Sure.
I got -3.
Did you get that?
Yes, ma'am.
Okay, well done. And then you took p to this side, and you took your 2 plus 3 to the side, and you got p is equal to 5. Okay, so in Nhlanhla used logs. You don't have to use logs if you don't want to. Okay, I'm very glad that you said that in Nhlanhla. Thank you so much. Your other alternative here, Matrix, is to write 1 over 27 as 3 to the power of -3. Okay, so you can make the bases the same instead of using logs. Okay, and then again, once you've got the bases the same, you can move your p to this side, your 3 to the other side, and you'd get the same answer that Nhlanhla gave us, which was p was equal to 5. Okay, well done. All right, now let's see if there are some questions. Okay, Nhlanhla, I think that was your hand up from earlier. Is that right? Okay, Amahle, go for it.
Ma'am, so I understand why we use the formula for the sum to infinity. But could you please re-explain that from the sum to infinity we got all the way to the logs part?
Okay, so in other words, when you are solving for an exponent, you can use logs. So it's like when you are working in financial maths and they ask you to calculate the value of n and you use logs. Okay, so if they give you an equation like this, let's say they give you 3 to the n equals 16. Okay, the number 16 cannot be written with base 3.
Okay.
Right, so we could use logs to solve the value of our exponent. So we would say our exponent is equal to the log of our base, which is 3 of the number 16. Okay, and then we could round our exponent off to however many decimal places that we needed. Okay, so that's exactly what Nhlanhla did over here. Okay, so 1 over 27 is our number, that's like the 16. 3 is our base, and 2 minus p is our exponent. So the exponent is equal to log base of our number. So exponent is equal to log base of our number. That's what Nhlanhla was doing. Okay.
Okay, thank you so much, ma'am.
All right, it's a pleasure. It's a pleasure.
Ma'am,
So
I've got one more question.
Of course,
Is there another way of doing this? Oh, okay, I see it now. It's in the pink.
Yes, yes. So because 1/27 can be written with base 3, that might be a little bit easier for you. Okay. Both are perfectly correct. Both will be marked accurately in your exams. Okay.
Thank you.
All right, it's a pleasure. Okay, so well done, Matrix. That was a slightly more difficult question, right? 5 marks. Obviously, we would get a mark for our answer. Okay, so a mark over here. If you are making the bases the same, they generally tend to give you a mark for that, or an accuracy on using logs. Then there would have to be a mark for subbing into your sum to infinity. So that is what, 3 marks. And then here, I think they would give you a mark for starting to sub in. And I suppose we could have also done this at this point over here. We could have also worked with it over there. It doesn't matter that we simplified it a little bit more, just makes it easier when we want to solve our equation at the end. So I guess there would be a mark for getting to this point as well. So 1, 2, 3, 4, 5 marks. Okay, are there any other questions?
I'm just going to run the poll while they're asking questions. Sorry.
Mako, I tell you what, I will do it at the beginning of the next lesson. Okay. And I'll show you how it's derived. I've got load shedding starting now. Please answer the poll before you go. Thank you. Okay, because it's 1/27, Zoom user. Okay, so 3 to the power of 3 is 27. 1/27 is 3 to the power of -3. Okay, Lebogang, I see you've got a hand up.
Oh man, can I ask, in the case like this, give you a pattern that switches between like a whole number and a fraction, a whole number and a fraction? You have to do this like in 2 separate steps.
No, not necessarily. Not necessarily. So, I mean, it's not going to switch, because you see your R is always going to be constant. So, if you start with whole numbers, you may end up with values that are going to be fractions. So no, not necessarily. It's not I know what you're talking about. It's where they combine 2 patterns together. So every alternate term is arithmetic and every alternate term is geometric. They don't generally tend to ask questions on that. Okay, so wouldn't worry about that.
Thank you, ma'am.
Okay, Lindelwa, where is the 1/27 coming from? Okay, so what we did here is we had to multiply both sides by 2/3. So when you multiplied the 1/18 by 2/3, that's where you got the 1/27. Okay, so you're multiplying by the denominator on both sides. Okay, that's where it came from.